Okay, on the back now. If you read those few sentences that start off the back side of the page, um, I talk about how when we graphed a system of linear equations, a lot of the times there's one solution, an ordered pair, like we've been doing. But sometimes when you graph, the lines don't cross, and the lines are parallel. And that means there's no solution. There's no place that solves both equations at the same time. Sometimes you graph the two lines and actually they're the exact same line. And that means they are intersecting. They're intersecting a lot. In fact, they're intersecting an infinite number of times. They're just continuously intersecting. Well, the same thing can happen when we use substitution, except we're not going to see the answer on a graph. And so let's see what that will look like. All right, so with number 5, I'm going to do this following the same steps. I need to get one of these letters by themselves. I mean, you can choose any of the 4 choices. I'm going to choose this y that goes with the first equation. I'm going to put that by itself. So I'm going to subtract the 6x. So I'm going to kind of take this minus 6x and minus 6x and then rewrite it. I will still have negative 2y. And then on this side, maybe I'll write negative 6x minus 4. Right, then divide everything by negative 2. It's important that you know that this is still negative next to the 2 next to the y. So we need to divide by negative 2. Okay, so when we solve that top equation for y, we end up getting positive 3x plus 2. So now we take the other equation, and we're going to write it. And I don't know what x is, so I'm going to write x. But when I come to y, we have figured out that y is 3x plus 2. So I'm going to put this in parentheses and substitute in for y 3x plus 2. And then that equals 10. Okay, so I need to distribute. The negative 15x is just going to hang out for a minute. Then I got to distribute the 5. So 5 times 3x is 15x. 5 times 2 is 10. And then that still equals 10. All right, usually at this point we combine like terms. So I have negative 15x and positive 15x. And so those actually cancel out. You add those together, you get 0x, which is just 0. So I am left with 10 equals 10. Now that is not my answer, because remember our answer is usually an ordered pair. But this kind of clues us in as to what the answer is. When the variables drop out, you either have a true statement or an untrue statement. You can see that 10 equals 10 is a true statement. And so what this represents are 2 lines that are actually the exact same line, and that means there are infinitely many solutions. Let's see if you can spell infinitely correctly. Infinitely, many. It's kind of hard to write with a mouse. Infinitely many, what was I writing again? Solutions. If the variable dropped out and we had an untrue statement, if we had a false statement, you might be able to guess what we would be writing instead of infinitely many solutions. But in this case, the variable drops out, we have a true statement. That means there are infinitely many solutions. It means really, even though these lines don't look like it, they're actually the same line. All right, let's do the next one, number 6. This one, we got to choose one of the letters to get by itself. It should be obvious that you want to get the first x by itself. if you look at it, it should just be clear that you want to get the x, because it's kind of already by itself. It's the only letter that doesn't have a number in front of it. So we're going to subtract 2y from both sides. I'm writing it down here, but really I mean for it to be the upstairs equation. So x equals negative 2y plus 8. All right, so I'm going to put that in the other equation for x, because that's what x equals. So when I write out the other equation, I'll have 2 parentheses negative 2y plus 8 and then just continue writing that equation without any other changes. Plus 4y equals 10. Oh, I don't know why I have 2 equal signs there. It really just should be 1. Okay, let's distribute. So that's going to be negative 4y plus 16. And I still have plus 4y. Ooh, you might see what's going to happen here. When I combine like terms on the left side, I have negative 4y and positive 4y. Those are just going to go away. They cancel each other out. So I'm left with 16 equals 10. No, it doesn't. 16 does not equal 10. So this is what it looks like to have a false statement. If the variables drop out and you have a false statement, that's not the answer. I'm just writing it down because it happens to be false. The answer here is no solutions. That means that if you graphed these two lines, they would be parallel and they would never intersect. They would not be the same line. They'd be different lines. But they would never intersect. Remember, the number of solutions is how many times they intersect. Most of them that we do, like numbers 1, 2, 3, 4, they intersect at one particular place, and that ordered pair is your answer. And number 5, they were intersecting continuously because they were really the same line, so we had infinitely many solutions. And number 6, they did not intersect at all, so we had no solutions. All right, your homework is to finish this worksheet. You have 3 problems at the bottom here. Help each other out, ask each other for help, and this is due tomorrow.